The internet is buzzing, and for good reason. A new open-source project called NanoVLLM has been secretly developed by a DeepSeek employee in their spare time. And it's completely shaking up the AI world. This isn't just another tool. It's a game changer that promises to demystify large language models and offer unprecedented performance. NanoVLLM is making waves because it's incredibly fast, remarkably clean, and astonishingly, it's written in just 200 lines of Python. That's right, no bloated frameworks, no mysterious complexities, just raw, stripped-down performance that can run powerful AI models at full speed, even on your personal machine. This project isn't merely competing with production engines like VLLM. It's revealing their inner workings step by step. It's a cheat code for anyone curious about the true mechanics of large language models. The fundamental challenge that VLLM addresses is speed. When you prompt a language model for an answer, a lot happens behind the scenes. Your text is broken down into numbered tokens. These tokens then journey through numerous layers of mathematical computations within the model. Finally, the software selects the next word. Large-scale engines like VLLM employ clever scheduling techniques to ensure that a single graphics card, or several working in tandem, never idles during this intricate process. This efficiency is crucial for handling massive workloads. However, the downside is that the VLLM codebase is incredibly sprawling. If you attempt to explore it to understand a specific feature, you can easily get lost in a maze of files calling other files, which in turn call even more files written in lower-level languages. This makes VLLM powerful, but also incredibly difficult to decipher. NanoVLLM completely flips the situation on its head. The brilliant author meticulously wrote every component in plain modern Python, complete with crystal-clear comments. The code is structured so you can seamlessly follow each step, from your initial input prompt to the final output, without getting lost in dozens of layers. It feels like a guided tour through the brain of a large language model. Yet, it still operates fast enough to keep pace with its heavyweight cousin in many offline tests. When I say offline, I'm referring to single-user tasks where you have a chunk of text ready for processing. Think research experiments, data labeling, or personal hobby projects, not the bustling public chatbots that need to handle streams of questions from countless users simultaneously. During the initial benchmark, the researcher utilized a laptop graphics card, an RTX 470 with 8 GB of memory, and loaded a mid-sized model called Qwen 3.6b to ensure a fair comparison. Both VLLM and NanoVLLM were tasked with generating text for 256 different sequences. Each sequence began with a random prompt ranging from 100 to 1,024 words, and then the engines produced another stretch of text of a similar length. In total, both programs generated an impressive 130,966 tokens. The older VLLM completed the task in 98.37 seconds, while NanoVLLM crossed the finish line at 93.41 seconds. This translates to roughly 1,362 versus 1,434 tokens per second. In other words, the newcomer was 5% quicker on that specific run, even though its entire code fits neatly on just 10 printed pages. So where does this speed come from if the code is so small? A handful of tidy but powerful ideas do most of the heavy lifting. First, NanoVLLM keeps a prefix cache. Imagine asking the model to complete similar openings repeatedly like, once upon a time. The beginning of that sentence produces the same internal values each time, so the program stores them the first time around and reuses them later instead of starting from scratch. Next, it supports tensor parallelism, a method of splitting the model's layers across several graphics cards, so each card carries part of the workload. There's also Torch Compile, a feature in PyTorch that bundles small operations together, allowing the graphics card to run them in one shot instead of many tiny bursts. Finally, it captures CUDA graphs, which work like pre-recorded instructions for the graphics card. Once the graph is captured, the card can replay it without extra chatter from the CPU. Each of these tricks is well known in large production systems, yet seeing them laid out in straightforward Python makes them feel far more approachable. Here's how NanoVLLM works in simple terms. When you give it a sentence, it breaks it down into tokens, which are essentially numbers the model can understand, kind of like translating your words into the model's language. Then, it runs those numbers through a streamlined setup that loads the AI's brain, keeps track of what's already been said, and figures out what should come next. It even adds a bit of randomness or filters out weird responses depending on how you configure it. All of this happens through clean, easy-to-follow code. No messy layers, no mystery tools, just small, focused files that walk through the process one step at a time. This is a significant breakthrough for anyone who genuinely wants to learn how these models function, rather than just using them. Of course, keeping things simple means letting go of a few bells and whistles. NanoVLLM isn't built to handle dozens of users at once, and it won't type out answers word by word like ChatGPT does. It also skips advanced tricks that make huge models run on tiny devices. But that's the trade-off. It's fast, clear, and easy to understand without the noise. When news of the release landed on the local Llama subreddit, the top comment quickly pointed out that this is strictly a personal project, not an official DeepSeek product. This distinction matters because companies often require extensive testing, legal checks, and customer commitments before they bless anything as official. A personal repository can move faster, try risky ideas, and let others learn from rough edges. In fact, many people in the thread cheered the hobbyist spirit. They compared NanoVLLM to NanoGPT, another famous tiny project that demonstrates how to train, not just run, a model in as few lines of code as possible. Installing NanoVLLM is surprisingly simple. You just paste one line into your terminal, and the whole thing downloads. Once it's set up, you load your model folder, adjust a few settings like how long the response should be or how creative it sounds, and then run your prompts. That's it. It even works almost exactly like VLLM, so if you're already using that, switching over takes just a couple of small changes. What really stood out in the tests wasn't just the speed, it was how efficient the whole thing is. Both NanoVLLM and VLLM produce the exact same amount of text, but NanoVLLM did it faster using only 8 GB of graphics card memory. That means it's doing more with less simply by cutting out all the unnecessary background noise. And that's why people are now trying it on more powerful setups with bigger models and multi-graphics card systems to see just how far it can go. Now, it doesn't support everything yet. There are more complex types of models like mixture of experts, where different parts of the model take turns depending on the question. NanoVLLM doesn't handle those yet. But because the code is so small and well organized, it wouldn't be hard for someone to add it. It's the kind of project that makes developers want to tinker, test ideas, and build on top of it. That's also why educators are getting excited. In a classroom, this is the perfect starting point. Students can actually read through the code, understand what's happening, and then try adding new features themselves. And because the basics are all here, how to handle inputs, store memory, and generate text, those lessons carry over to the bigger, more complex frameworks used in real-world applications. There's also a neat little feature that makes it easier to learn from, a setting called Enforce Eager. When it's on, the program runs step by step, which makes it easy to test, explore, or debug. And once you've got it working the way you want, you can flip the switch and let PyTorch optimize everything behind the scenes for better performance. On top of that, it uses CUDA to speed things up by recording a full path once and replaying it, which saves time every time it runs. Now, if you're running a big production system with lots of users and real-time traffic, NanoVLLM probably isn't what you'll rely on. VLLM is still the tool for that. It's been battle-tested, tuned, and scaled to handle serious workloads. But if you're learning, experimenting, or building smaller tools that don't need to support thousands of users at once, NanoVLLM gives you almost the same power with way less complexity. What's truly inspiring about this project, though, is how much one person was able to accomplish with clear, focused code. No clutter, no over-engineering, just a smart design that works. Developers on Reddit were actually excited to open the files and see exactly what each piece was doing without having to dig through hundreds of extra lines. That kind of simplicity opens the door for more people to get involved, especially those who have ideas but get overwhelmed by giant code bases. Of course, how well it performs depends on your setup, how big your model is, how long your prompts are, how much memory you have, and whether you need responses to stream in real time. The benchmark on a laptop shows what's possible, but results will vary depending on what you throw at it. Still, it proves that you don't need a massive system to get impressive speed. And now that it's out in the open, the project will evolve the way all great open-source tools do, through community contributions. Anyone can jump in, add new features like dynamic batching or mixture of expert support, and help shape where it goes next. It's exactly how projects like PyTorch and TensorFlow got started. Small, powerful ideas that grew with help from people who cared. So what do you think? Could something this small really shift how we build and run AI models? Drop your thoughts below. If you found this interesting, make sure to stick around. There's a lot more like this coming. Thanks for watching, and I'll catch you in the next one.